This is geometry 4.5. We're going to prove triangles congruent by side, angle, side. Notice the A is in between the S's. That's called the included angle. The angle is in between the sides. Included angle. We can demonstrate that a little bit. If I have a pair of sides, and I'm going to make an angle out of them, or with them. These two angles are exactly the same. Okay, try to demonstrate that. Line them up right on top of each other. Same angle. So when I put them in between this segment and I change the angle so it matches. So they both figures here have an orange and a purple, and the angle in between is exactly the same. What this tells us is that these two triangles, the triangle that would be made here, would be exactly the same size and shape as the triangle that's here. We know that because we can measure. If we measure the length, it's kind of tough because it keeps moving. But if we measure the length, we get about 6.3. And over here, we'll see that that other side is exactly 6.3. So that's telling us that the third side has to match. Now, if the angles didn't have to be congruent, if they could be different, then of course that third side is going to be much different, much longer. But if it has to match this one here, then that's enough to prove the triangle's congruent. So that's a new way we can prove triangles congruent, is by side, angle, side. The A has to be in between the two sides. So we have that here. Side, angle, side. If two sides and the included angle of a triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. RS has two tick marks, and it's going to be congruent to UV. Angle R has one tick mark. It's going to be congruent to angle U. Segment RT is going to be congruent to UW. So triangle RST, I go from the marked angle up the two tick mark side and down. So this has to be triangle UVW. R and U are considered the included angle because they are the angle that are in between the two given sides. Angle in between. So what we're going to do is come down here for our first example and try to identify what is the included angle. Name the included angle between these two sides. So if we look at GH, GH is right here, and HI, that's over here, what angle do those two sides make? These are the two sides, GH and HI. What is the angle that is made between those? Angle H. That's considered the included angle. It's the angle that's made by those two segments. Let's look at these two segments. HI and IG. There's HI, and IG is over here. So what angle is formed by HI and IG? What angle is this? Some people make a mistake and they call that angle I. Watch this carefully. They call this angle I, and that's not correct. You can't use just one letter to name this angle, because there's a whole bunch of angles happening here. You have to use H, I, G. The I is going to be the vertex, so it has to be the middle letter. And we use the angle symbol out in front. That would be the angle that is formed. H-I-G, or you can name it G-I-H. Okay, what about these two segments? G-I. We could use a highlighter for this one. G-I and I-J. What is the angle that is formed between those two segments? Remember, you cannot use one letter if there's a whole bunch of angles happening from that spot. So correct, G-I-J. You got to use three letters. G-I-J. Or you could call it J-I-G. That is considered the included angle. That's the angle that's in between the two given sides. Decide whether enough information is given to prove the triangles are congruent using side, angle, side. So we look here. We notice that both triangles have a 1 tick for a side. They have a given angle. Little difficult to see that, but an angle in between. And they have the 2 tick side. Look at the order. 2 sides, and the angle is in between those sides. It's the angle that's formed by the blue and the green. That's the angle that's labeled. So triangle PQT, down the green side, then down the blue side. So we have to name it RQS, down the green side, down the blue side. By side, angle, side. We know these triangles are congruent because we have a side, an angle, and a side in both triangles. Let's look at this next picture. What do we have here? I have a pair of 1 tickers the same. I have a pair of 2 ticks the same. So that's 2 bits of information I know for sure. Is there anything else? Do I need anything else? Do I know anything else? We can't use side, side, side because I don't know about the third sides. Notice that we have a big X that's being formed. We have vertical angles. Angle JKN is congruent to angle MKL. If vertical angles, then congruent angles. So I know those angles are congruent. So I can say that triangle NKJ, up the blue, up the green. So I'm going to go up the blue, up the green. LKM. Those triangles are congruent. And that was by side, angle, side. Both triangles have a green, both triangles have a blue, and both triangles have the angle that's in between the blue and the green. Side, angle, side, the included angle. Okay, let's take a look at letter C. Notice how both triangles have a 1 tick mark. Notice how both triangles have an angle that's the same. That's the given information that they show us. Is there something else we know for sure? Do we have vertical angles? Do we have a midpoint? Do we know that for sure? No, we don't know that for sure. Do we know anything else? I see this segment that's sitting in between them. This segment is the same in both triangles. It's called the reflexive segment. So both triangles have a green side. So this looks like we have a green, a blue side, and the angle in between. But when you look at this triangle, we have a blue side and a green side, but the yellow angle's not in between those blue and the green. It's not the included angle. They don't match. It has to match exactly, and the angle has to be in between them to use SAS. So that's not going to work. Angle ZXY is not the included angle. It has to be the included angle. So triangle WXY is congruent, not, so not congruent, that's when we put the line through it, to triangle ZXY. Because the information is not in the same pattern. It's kind of tough to see sometimes. Here's one of my favorite type of questions to ask. You'll see this on a test or a quiz. State the third congruence. Third congruence. That's going to make the two triangles congruent to each other. So here we have triangle ABC. So I would suggest to you to actually draw a triangle ABC and draw a triangle FED. Put the letters in any order you want. They tell us here that AB is congruent to FE. You can put a 1 tick mark on that, or if you prefer the colors, you can mark them with the color. The other pair of sides, AC, is congruent to FD. We know those are congruent. Now they want us to prove these triangles congruent using SSS. Side, side, side. So what's the third congruence I wish I knew if I was thinking about proving these triangles congruent by SSS? What do I not know, but what do I wish I knew? I need BC congruent to ED. Then I would have side, side, side with each triangle. That's the third bit of information I don't know. 1, 2, and 3. Okay, let's try this triangle. We'll do ABC. We'll get crazy. We'll draw this one different. Put the letters in any order you want. F, E, D. We know that angle B is supposed to be congruent with angle E. We know that angle or segment AB is congruent to segment FE. So if we're going to use SAS to prove the triangle is congruent, what's the third congruence? What's the third bit of information I need? I have a pair of angles, a pair of sides. What's the third thing I need to know for sure? We need to be sure the angle is in the middle. If you take a look, the one tick mark is in blue. The angle that we know is in yellow. So now I need my third pair of sides to be BC congruent to ED. That would be my third congruence. I have a side, I have another pair of sides, and I have my included angle. Perfect. All right, writing a proof. Notice that some of the parts are already written for us. That's helpful. In your last night's homework, you didn't have any parts written. The given information is where you want to start. You don't just start filling in stuff. You have to study what they tell you. B is the midpoint of AE. There is AE. B is the midpoint of AE. So what does that mean? What good is that? Why do they tell me that? That tells me that I have a pair of congruent segments the same. I also know that B is the midpoint of CD. It's got a double job. It's the midpoint of two different segments. So if it's the midpoint of C to D, then I know I have a pair of segments congruent there. There's no reason I know these segments are congruent, so I'm never going to be able to use side, side, side. So what's my other option? Side, angle, side? Is there any reason these angles are congruent? Vertical angles. You got a big X, you're going to have vertical angles. All right, so we did it. We proved the triangle's congruent. They both have a one ticker, they both have a two ticker, and we have vertical angles. So we have a plan. So we're going to say B is the midpoint of AE and CD. That's our given information. Now, what good is knowing about a midpoint? Why do we need to know about a midpoint? What does that tell us? What do we mark up in our picture? We have segments equal to each other. If midpoint, if a point is a midpoint, then it's going to divide that big segment into two congruent parts. So I say then two congruent segments. Trying to shorten it up. Here's the formal way to write it with some abbreviations. But it's got a few extra words. If you want to use those few extra words because that makes sense to you, that's okay. But if there's a midpoint, then what do you get? Two congruent segments. That's what they're talking about. If comes earlier, then is happening right now. So what's going to go here? It looks like they've got the same exact statement again, or reason at least. Same exact reason. What statement are we going to use? What haven't we talked about? DB is congruent to CB. We have the midpoint. When B is the midpoint of AE, we got this to be congruent. And now we have B, the midpoint of CD. We have these congruent. So I have a pair of sides congruent. I have another pair of sides congruent. What's this? Where's this come from? Can you trace them out? A, B, D. ABD. EBC. Why are those two angles the same? Why are they saying these match? We talked about it earlier. If vertical angles, if has to come earlier, so it's coming from the picture. We don't have to label it in our proof about being vertical. It's in the picture. We got a big X. So if vertical angles, if we have vertical angles, then congruent angles. So here, the way we proved it was a pair of sides, and then an angle. But it's not really in SSA format. It's actually not a way you can prove triangles congruent. We'll talk more about that in the future. It's not SSA. The A is in between the S's. So what are we going to say is our reason that triangles are congruent? What goes into this blank? The only reason. You have two choices of what to pick, but it only goes when triangles are congruent. Side, angle, side. We talked about a pair of sides, then a pair of angles, then a pair of sides. Side, angle, side, congruence. Last one. What's the first thing you see when you look at this picture? I see parallel lines. I see these arrows. The arrows indicate parallel lines. And every time you see parallel lines, this is what you think of. Can you find one of these sets of angles? And the very popular type right now, we're going to have it a lot, very popular type is going to be formed by the zigzag. And that creates alternate interior angles. Those are going to be congruent. Notice that we're trying to do this proof before we start filling it out. We're making a plan. Create a plan before you do your proof. Convince yourself this is possible. You have a pair of sides congruent. That's the one tick mark. Just because they're parallel does not make them congruent, so they had to tell us they were congruent. I have a pair of sides the same. I have a pair of angles the same. I'm missing something. I need something else. What else do we know for sure? You notice that this segment here is the same in both triangles. It's going to be the reflexive property. Now I have a side angle side. I'm ready to do my proof. I've convinced myself this is possible. So I know that AB, segment AB, is parallel to segment CD, and segment AB is also congruent to CD. They have to state them both because just being parallel does not make them congruent. All right, so we know that for sure. Now we're going to talk about angles. If parallel lines, since we have parallel lines, then alternate interior angles are congruent. That's the angles. That's where they came from. That was the zigzag. Now they want to talk about CB. Now I would write them in opposite order. I would say C to B on this triangle, but B to C for that one. No big deal. Reflexive POC. What you're trying to prove is always the last thing that you write. Do we have enough information? Did we get a pair of sides being congruent? Did we get a pair of angles being congruent? Did we get another pair of sides being congruent? Hey, look at that. So side, angle, side, congruence.